this lesson about complex numbers. I'm not going to really talk too much about the history of complex numbers and where they come from, but I am going to link a really cool video series down below that you should definitely check out, explaining where did imaginary numbers come from, who thought of them, how do they make sense in the world around us. So it's a really cool little video series. I'd recommend you check out at least the first few. We're just going to talk about kind of the basics of complex. So complex numbers, right, or the complex number system. Complex numbers are numbers that can be written in the form a plus bi, where a and b have to be regular old real numbers, and I is the imaginary unit. Now, imaginary units sound scary, but in math, unit is just the word that we use for one. Okay, so the number 1 is our unit in math, right? Our imaginary unit is I. So I, by definition, is the square root of -1. And I squared, by definition, is -1. Okay, those are two things that you just need to know cold, like not even any kind of a hesitation. You just know I is the square root of -1 and I squared is -1. Okay, so now we're going to use that as we simplify some radicals that have negatives in them. So this one right here, we got the square root of -4. So we're going to break this into the square root of 4 times the square root of -1 using just our regular old radical properties. And then from there, the square root of 4 is 2, and the square root of -1 by definition is I. So that's just going to simplify to 2I. I would not expect you to write out this step. I would expect you to jump right to here. I'm just kind of showing it out now so you kind of see what I'm doing. All right, square root of -9, I'd break that into the square root of 9 times the square root of -1. And then same deal, square root of 9 is 3. The square root of -1 is I, so it would be 3I. Okay, so similarly, the square root of -25 would be 5I. All right, well, what if we have a square root that doesn't simplify perfectly like this one? Well, for this problem, we'd break it into a product where we have our largest perfect square, 4 in this case, and then multiply that by the square root of 4. I'm sorry, multiply the square root of 4 times the square root of 3 times the square root of -1. Square root of 4 is 2. Square root of 3 doesn't simplify, so we just leave it. And the square root of -1 is I. By convention, we usually stick that in there between the 2 and the square root. Okay, so it comes right in front of the square root. Some people will actually put the I at the end after the radical. It's kind of one of those things that, like, if you went to a store and you looked through a whole bunch of different math books, you'd see some people putting them here and some people putting them there. It's just one of those things people do differently. I personally always prefer putting it here, just because if you put it at the end, I feel like it kind of can blend in whether or not it's inside the radical or outside the radical. So that's kind of why I like putting it there. All right, this guy right here, so square root of -8 squared, squaring and square rooting are inverse operations. They cancel each other out. So that's just -8, okay? Now, this guy over here, it's going to just be -10, same way. But I do want to point something out to you that's a common mistake with these. So when you see a problem like this, what'll happen sometimes is people think, oh, well, I have to multiply the square root of -10 times the square root of -10. And I know that with radicals, when I have two separate radicals, I can multiply them together to make one big radical. So -10 times -10 is 100. And then the square root of 100 is +10. Okay? That is wrong. Don't do that. Okay? When you're doing these, if you were going to break this apart into the square root of -10 times the square root of -10, you need to pull the i's out first. So you'd have I root 10 times I root 10. And then the root 10 times root 10 would give you the whole number 10. I times I is I squared, which by definition is -1. So -1 times 10 is -10. Okay, again, that's the long way. Just do it like how we did here, right? Squaring and square rooting cancel, and you're all set. All right, so that wasn't too bad. So the next piece that we're going to look at is the powers of I. So what do I mean by that? If you kind of preview these problems down here, I'm talking about when you take the imaginary unit and you're raising it to different exponents. Okay, so we're going to take a look at what happens with those by building a pattern here. So I'm going to make a lovely little list. I'm going to start with I, right, which by definition I is the square root of -1. And then I'm just going to write equals I again at the end here. You'll see why in a minute. I know that's totally unnecessary. All right, I squared by definition is -1. You just need to know that. All right, so then I to the 3rd power. So when I'm trying to raise I to the 3rd power, to figure that out, Remember, if you're multiplying like bases, right, and you have exponents, you add the exponents, right? So if I want to figure out I to the third, if I do I times I to the second, that's got an exponent of 1, right? So 1 plus 2 would give me 3, so that's I to the third, right? So if I want I to the third, I just need to multiply together I and I squared, or I and negative 1. So that's going to multiply to negative I. All right, I to the fourth. So we could do this one kind of the same way where we do I to the third times I to get up to 4, right? But what I'm actually going to do instead is I'm going to do I squared times I squared, which I'm doing this in my head, because 2 plus 2 still gets me to the 4, and then I'm just doing negative 1 times negative 1, which is positive 1. So that was easy. All right, make a new column. Trust me on this, make a new column. I to the fifth. Okay, well, it's really convenient. We got this nice pretty 1 here. I'm going to use that. So I to the fifth, I need 4 i's and then 1 more I, right? So that's I to the fourth times I. So it's 1 times I, or I. Okay, I to the sixth, right? Well, that's I to the fourth and then 2 more i's, right? So it's 1 times negative 1, negative 1. All right, I to the seventh, that's 4 and then 3 more. So 1 times negative I, so negative I. And then I to the eighth, well, 8 is 2 sets of 4, right? So I to the fourth times I to the fourth, so still 1. New column. You should be noticing something about these numbers. Okay, well, I to the eighth, we got to another pleasant little 1. So when I want to get up to 9, I'm just going to multiply that by another 1. 1 times I is I. I to the 10th is 8 and 2 more, so negative 1 times 1, negative 1. I to the 11th is 8 and 3 more, so negative I times 1 is negative I. And then I to the 12th, right? You're doing 8 and then 4 more, so 1 times 1 is 1. And you should be noticing that we have this lovely cyclical pattern between what these values end up being, which is super cool and super useful. So you may be thinking to yourself, why does it do that? Let's talk about that. Okay, so if you watched that video at the beginning of class, you kind of got an idea of what the lateral numbers look like, right? So here's a regular old number line, right? Here's 0, here's positive 1, here's negative 1, okay? So we talk about imaginary numbers. They are essentially numbers where you're adding a new vertical axis, a new dimension, where positive I is up here and negative I is down here. Okay, now when you think about the number line and we think about doing operations on a number line, right? You know how it works. Here's a number on the number line, right? If I add to it, it's going to just get slid over, right? If you multiply, it gets stretched out longer. When you multiply by a negative, that's like a 180-degree turn on the number line, right? So that's why when you take a positive number and you multiply by a negative, you end up with a negative answer. And when you have a negative number and you multiply by a negative, you end up with a positive answer, right? Because you're doing this flip, this 180-degree flip over the x-axis. Cool. So what happens when you're multiplying by I, okay, is that multiplying by I creates a quarter turn, a 90-degree turn. So with our little cycle here that we did, we started up here at I, and when we multiplied by I, that's a quarter turn. We ended up over here at negative 1. Multiply by I, do another quarter turn. We ended up down here at negative I. Multiply by I, it's another quarter turn. We ended up at positive 1, right? Multiply by I, quarter turn up here. Then another quarter turn, another quarter turn, another quarter turn, right? So that's where you get this cycle where it's just going through these same 4 numbers over and over and over and over again, okay? So when we look at these problems down here and we're trying to figure out what do these simplify to, all that we need to do is figure out, well, where in the cycle am I? So these first here are pretty straightforward. They're actually in our list. 5i squared. So you just need to know that that means 5 times I squared is negative 1. So that's negative 5. Again, I wouldn't expect you to write this out. You can jump right to that answer. This guy here, 3i squared. Well, 3 times 3 is 9. So that's 9i squared. I squared is negative 1. So that's negative 9. 2i to the third, 2 times 2 times 2, 8, not 6. Be careful about that. And then I to the third, that's in our list. That's negative I. So 8 times negative I, negative 8i. All right, this guy over here, so negative 3 to the 4th power. So 4 negatives, that's going to work out positive. 4 threes, that's 9 and 9. So that's 81, right? So that's 81 I to the 4th. And I to the 4th is just 1. So that's 81 times 1, 81. All right, well then what about these guys? So now I'm jumping up here, and now I'm looking at 23. Great. Okay, so 23 is a much bigger number. I don't want to have to follow this pattern all the way up till 23. But here's a handy little thing. All of the multiples of 4 always end up being 1 in my cycle, right? So what I do is I use that as my staple marking point, okay? So when I want 23, what I want to do is figure out, well, what's the nearest multiple of 4 to 23? Which in this case would be 24, right? So I know that I to the 24th would be here in my cycle. So when I want I to the 23rd, that would just be 1 above it, right? So I to the 23rd is negative I. So 4 times negative I, negative 4I. All right, 82, I to the 82nd. Well, what's my nearest multiple of 4 to that? 80 or 84 are the two easy ones. So if you picked I to the 84th, that's here. I to the 82nd would be back 2, right? That would be up here. So that's the same as I squared negative 1. So 5 times negative 1 is negative 5. If instead of doing 84, if you had gone with 80 instead, right? So I to the 80th, then you just kind of have to say, okay, well, if I to the 80th was here, right? Then in my next cycle, 81 would be up here and 82 would be here. And you get to the same spot. All right, 3i to the 48. Well, 48 is a multiple of 4. So I already know that that's 1. So that's just negative 3 times 1, so negative 3. And then 37, so closest multiple of 4 to 37, 40 is pretty easy. So I to the 40th would be here in my cycle. So then 39, 38, 37 would be at the top. So that's just an I. So this simplifies to 15I. Okay, so looking at these, right, you gotta know what this cycle is, all right? Personally, I don't want to memorize this whole cycle. I think that would be an obnoxious thing to have to memorize. What I always do with these problems is I just figure this out. I just do this cycle exactly the same way that we did. I know this one's I know this one's negative 1, multiply them together, oh, that's a negative I, square this one, oh, that's 1. Then I got my cycle and I'm good to go from there. If it helps you, you can do this one, right? If you, instead of having the algebraic way, if the geometric way works better for your brain, then use that, right? Anytime that you're somewhere, you just follow along this cycle. You just have to remember that you're starting up here at I along your cycle. Okay, so either one of those would work, but you are going to want to be able to simplify these problems. All right, and that is a quick introduction to how you use complex numbers. So complex numbers are just numbers that have an imaginary part to them, and we're going to keep working with those over the next few videos.